troubleshooting of op-amp circuits. Okay. So you know the basic of operational amplifier. கேக்குதம்மா?
Yes, sir.
Yes, sir.
Operational amplifier. So all of you know that an operational amplifier is a voltage amplifying device. This capacitors between the input and the output terminals. It is a high gain electronic voltage amplifier with a differential input, usually single output. So op-amp consists of two inputs and one output. Op-amps are most widely used electronic devices today. It is used in consumer, industrial, and scientific devices. This is a symbol of op-amp. If you look at that symbol, it consists of two inputs and one output. One input is called inverting input, and the other input is called non-inverting input. Okay. So based on the difference between the two input V1 and V2, it produces the output. Next one, the characteristics of op-amp. So there is an ideal op-amp that has some characteristics and which differs from the real op-amp. An ideal op-amp, infinite voltage gain. A real op-amp can only produce a finite gain. Ideal op-amp, infinite high input impedance, whereas a real op-amp has finite input impedance. Ideal op-amp has zero output impedance, whereas a real op-amp always have some output impedance. In ideal op-amp, gain is independent of frequency, whereas in real op-amp, gain is dependent of frequency. And ideal op-amp, zero input voltage offset, whereas in real op-amp will have slight offset even if the voltage applied to the pins are same. And output swings instantly to the correct value. In real op-amp, the amplified signal will take time to reach the fully amplified voltage value. This is about the characteristics. And then op-amp parameters. Open loop gain is the gain without positive or negative feedback. And input impedance, that is one parameter. Open loop gain is one parameter. Second parameter is the input impedance, which is the ratio of input voltage to the input current. Okay, so it is assumed to be infinite to prevent any current flowing from the source to amplifiers. The output impedance is the third parameter. Is of the ideal operational amplifier assumed to be zero. In an ideal op-amp, the output impedance is zero. This impedance in series with the load, thereby increasing the output available for the load. And a fourth parameter is the bandwidth. The bandwidth of the ideal operational amplifier is infinite and can amplify any frequency signal from DC to the highest AC frequencies. Fifth one, the ideal output of an amplifier is zero when the voltage difference between inverting and non-inverting inputs is zero. As I told earlier, an op-amp consists of two inputs and one output. The operational amplifier responds to the difference between the two voltages V1 and V2 irrespective of the individual values at the inputs. External resistors or capacitors are often connected to the op-amp in many ways to form the basic circuits. Some of the basic circuits are inverting amplifier, non-inverting amplifier, voltage follower, a summer, differential amplifier, integrator, differentiator are some of the basic op-amp circuits. Operational amplifier is available in IC packaging. The most commonly used is 741, IC 741. Next one, troubleshooting of op-amp circuits. Troubleshooting of op-amp circuits. So as a troubleshooting nothing but diagnosis of any fault present in the circuits. So the ability to diagnose and cure problems in a systematic manner and carry out quick and easy checks first. Start with a visual inspection, then use a multimeter, finally an oscilloscope, just to find out the any fault in the op-amp circuits. General checking. Is the circuit diagram open and how it is working? You should know all those things. And you should know the pin layout, how many pins in the IC and the polarity of the each device, all should know in prior. Power and grounds. In troubleshooting, you have to check whether power supply is working. Check the stable outputs with a digital multimeter. Are the op-amps connected to both supply rails? Check voltages. Check voltages with respect to ground at pins of each device. And then you have to check whether the ground rail is continuous. Check voltage between power supply rail and the points on circuit that should be ground. These are the various things you have to check. Are the resistor and capacitor values are correct? If the values are not correct, then the circuit will not work properly. You have to check those values with the help of multimeter. Second one, are the potentiometers being used correctly? You have to check the wiper voltage varies in a reasonable manner as the potentiometer is adjusted. Third one, are switches of correct type? You have to check. Have you checked your assumptions about which terminal is with a digital multimeter? Op-amps, checking op-amp if faulty. If op-amp is found faulty, what are things you have to do? Check by replacing the op-amp with another op-amp. Second one is you have to check each pin of the op-amp. Check visually that none of the pins have become wrapped, whether they are inserted properly or not. Okay, and then is the output is finite. If the output is within a volt or so, either power rail, then either it has failed or there is an excessive voltage at its input. Third one, you have to check is the input consistent with the output. So this we have done by measure the voltage between inverting and non-inverting inputs. It should be within millivolts of 0. Next one, offset voltages and instability. You have to check. A few millivolts of offset at the input of a system with a high DC gain can be amplified to the point that it saturates from the final stage. Many op-amps have offset adjust facilities which can reduce the offset by something like a factor of 10. Instability. So instability typically appears as high frequency fuzz on the output signal oscilloscope trace. Breadboard circuits are very prone to it because of inter-track capacitance and long components leads. These are the general points about troubleshooting. organize the physical layout of the circuit to keep the input and output stages separate. Decouple the board power supply rails with a capacitors to the ground. Work out the loop gain based on the manufacturer data sheet. And you should not use a op amp with an unnecessarily good frequency response. And this is the last one, fault finding by a method of divide and conquer method, troubleshooting method, which is applicable for an op amp that is involved in a complex circuit that has several stages. So in that case, you have to divide the entire circuit into sub-circuits and then test the sub-circuits individually. If you want to do an open loop test on a closed loop system, use a signal generator or a voltage source to inject a simulation of the closed loop signal at the point where open the loop. Check the signal at the input and output of each section using an oscilloscope if appropriate. It is possible for a faulty section to load its predecessor in the chain.